Welcome to myCTalkthroughs. These videos, which I will talk you through, are small bites presenting features of the C programming language. Short here means as short as possible, but as long as necessary to understand the main concepts presented. This is not a TikTok video for which you need the attention span of a housefly. Today I will have a look at a feature which at first glance even your smartphone covers, but do not be confused by the prefix smart here. Your mobile, as any other computer, is particularly good at one thing only: efficiently adding up numbers. But when it comes to exceptionally large numbers, like the number of sand grains on the world's beaches, the amount of stars in the galaxy, or the average level of stupidity of the drivers on the highway in front of my wife's car, as she says, the standard library in C often gets us nowhere. Unlike real numbers, integers are stored in binary as is. The bits are read and values set. The only limit on an integer's value is on the number of bits in the binary chunk, the bit width, which sets the values range, positive and negative, or just positive. For most computer systems nowadays, the largest integer value is based on the word size of 64 bits. In C, this size is a data type long or long. The values range from, now I have to get you some numbers here, but they are so big I dare not to speak really out. So it's time to switch to an editor, and here you see it ranges from this number here to this number. And the unsigned value is large enough that the scientific E notation is required, but in this case I just say 2 to the power of 64 minus 1. Until the 128-bit era dawned for PC and Linux boxes, the unsigned long is as big as you are going to see from a normal integer value in C or on any computer system. First, I thought about to present you some demo, like, I will show you here. With this, I wanted to show you how big an unsigned long is. Here I initialize or declare and initialize a variable I as long unsigned, and then I just thought about to count through and print out after every count. But if I run this, you clearly see that it comes very quickly to an end, and basically you see nothing. But as I see it here, the compiler itself already optimizing my output array, does a calculation before it is sent to std out or something. I need to make a little change here, and that change here looks like this. I will show you. This here I can just comment out, right? So, I will do that here. C. And then I add up this code here. It looks very similar. I need also std out here, std input output. So I will add that. So here you see I start a loop, and my idea was just to let it run and output each number one after another. And as you see, at least it works. the program now outputs values from 1 to, and now again, here's a really, really big number coming up. I have to just put it in here, up to this. As you can imagine, it takes quite a while for such a program to run, and it runs fast, but mostly it is so slow and makes so much output because the screen output is just slow. We have to give up it running. My best guess it would run a week or more. It would take the program to finish. When the output is suppressed, however, like here, this is not outputting anything, but it is clearly going through all the numbers and counting, one after another up. In this case, it takes 0.03, before it was even faster, seconds, so basically 3 milliseconds to run. That is the time it takes the computer to count from 1 to 2 to the power of 64 minus 1. At least in some way it is that time. So imagine how much longer it would take such a program here to run if the upper limit of an integer goes to 128 with, or 256 with, or an infinite number of bytes. Well, you don't have to imagine. That is because the gmp library exists. It extends the C programming language's capabilities to deal with integers of nearly infinite size. In this series, I did not want to cover C programming beyond the standard library, but promise given, promise broken, and according to my personal life motto, what do I care about my babbling from yesterday? I do exactly that here in my first episode. It is necessary, and we have to add a new library and make our compiler have access to it, the gmp library. The full name of the is GNU Multiple Precision Arithmetic Library. For people who love acronyms, it should be called GNUMPEL, but that sounds like a dwarf hero in the Lord of the Rings, so not like a programming library. GMP is much more catchy. The GMP library may be pre-installed on your computer, though probably not. You must use the Linux package manager coming with your favorite Linux flavor to obtain and install the library. This step adds the required header files and libraries. After that, you can play around with massive integer values. On my Linux system here, it is an Debian derivate. I have to install libgmp-dev package just with sudo apt-get install libgmp -dev. That asked me to give my password for that, and afterwards the library is available. If you are on a Mac, you can use the homebrew program to obtain the package. The command is then brew install gmp. Much more easy, right? So, and to confirm that the package is really installed, I prepared you the following code here. I will quickly comment this here out. And then we have a look at this. This already includes the GMP header file, and it then outputs nothing else but the included header number, version number, sorry. Nothing else, and that gives us the version number 60201. So it may be different on your computer depending on the version your package manager supports. But upon success, meaning the compiler sees the GMP header file, you can confirm that with the GMP library is installed. With that you can confirm that the GMP library is installed on your system. Compiling code that uses the library's functions requires that you use the -L for library, respectively linking, GMP switch. So you have to link against the library with -L GMP switch when compiling. So if you are working at the Large Hadron Collider at CERN and you sneaked out of the room to watch this video after you messed up with your code for an experiment with a particle accelerator, the option -LGMP needs to be added last at the command prompt if you run your compiler manually. And as you see here I use code blocks. And here I have to open the settings for the compiler, and in the linker settings, I just add here L or -L GMP. And from that moment on, my compiler or my IDE will talk to my compiler and tell my compiler to use this switch when compiling programs. So if you work with another IDE, you have to set that according to your IDE settings. After confirming that the library is installed, and the next step isn't to code, but rather to check through the online documentation, the API or application programming interface. For the GMP library, which handles painfully large integers, you can find that, you can find that right here. I will give you the link, which comes gmplib.org/manual/index. So don't expect any hand-holding here. Programmers write to other programmers. Often they are so immersed in the topic, they forget about people who are just starting. The pros will not pamper you with nice explanations here, but that's okay. It's the reason you are watching this video, and we are just having a quick look at the manual. Here on this page, you can click through from the first page. It is about the types which are here within this library, and the GMP integer values are stored in structure casts as the MPZ_T data type. I assume the structure contents are revealed somewhere in the library's website, though knowing the details isn't necessary. So to use the large integer values, you must follow certain procedures and use the specific functions available in the GMP library. Due to its composition, the MPZ_T data type requires 3 steps to initialize. You cannot use the equal sign operator to assign a value. First step is to declare the MPZ mpz underline t variable. Second is to initialize a variable. And third is assign the variable a value. So declaration is kind of trivial already. I prepared here, of course, again, a little example for you again. So I copy that quickly in and we have a look at and talk it through. That was the wrong one. Here we go. So I include the gmp header file, and after that, with mpz underline init, mpz underline and the identifier, I do declaration. This statement creates an mpz underline t variable, I. It allocates the structure, but like any variable declared in C, the content at this moment is garbage. A second step is required, and that is this one here. mpz underline init. The mpz underline init function initialize variable I, setting its value to 0. The variable can now be used in the host of mpz and gmp functions. And to assign a value to the mpz variable, you use one of the mpz underline set family function. So a function family, better to say. mpz underline set underline ui. That assigns an unsigned integer. That is the underline ui, value of 1 billion to I. So the variable can now be used in your code, but only with special functions. For example, gmp print, here, gmp underline print is such a function shown in this line, and the gmp print function at line 10, is it line 10? But for me it's line 11, now it's line 10, works like the standard printf function, though it is capable of outputting mpz underline t values. And here the percent uppercase ZD placeholder outputs an mpz underline t value as a decimal number. So let's run this. And as you see, wow, that's really impressive. Our code outputs a 1 billion. For the younger generation, it may be the information technology's biggest achievement, that you now can watch YouTuber watching other YouTubers videos, clips, playing an online game and comment on that. For programmers, though, to see such a large integer on the screen can be a disclosure, a revelation, even the beginning of an epiphany. But this code is start only. I sarcastically quote here Eric from Roger Avery's movie Killing Zoe from 1993. Good. Now we do heroin. Yeah, as I said earlier, various mpz underline set functions are available to assign specific values to mpz underline t variables. For example, mpz underline set underline si to assign a signed int value, mpz underline set underline d to assign a double, and you can even convert a value from a string. The library also hosts functions that read standard input for assigning values, such as gmp underline scanf. The manual lists a lot more you can find out on your own. We will now cover some basic math and carry out some MPZ_T value manipulations. As you know, you can't use the equal sign to assign an MPZ_T huge integer value. You can use the standard arithmetic operators to do math. Nope, you must use special GMP library functions to do the math, big math in this case. So addition is where math teaching begins, probably because a 3-year-old already understands the concept of more very quickly. The function here is MPZ_add and has 3 arguments: the result, value 1, value 2. All arguments need to be initialized MPZ_T values, which makes this function's equivalent of result equals value 1 plus value 2. And here we go. I will copy this code now here in, and then we have a quick look at it. So, copy this, I comment out like before, and I add that at the top. We include GMP library and variables a, b, and x are declared at line 5. These values are initialized at line 8 to 10, which sets their values to 0 and allows them to be used in further functions. If you attempt to use an uninitialized value, the program, respectively the compiler, may barf at you pointers in the MPZ_T structures are uninitialized. On the other hand, your program may come to some result, but debugging something like this, if it is your part in a team project, may become so time-consuming that you are the last one who commits and has to merge all the other developers' commits. So better take care about initializing your GMP values properly from the start. So values for variable a and b are assigned here on line 13 and 14. The math, some people call it the magic, happens at line 17 with the MPZ_add functions. Values a and b are added with the result stored in variable x. Line 19 then outputs the result with the function gmp.h, and we have a quick look. As you see, 3 billion plus 5 billion equals 8 billion. Now you know that. And remember, if you compile this code on the command line, you have to add the -l GMP switch. Of course, with the GMP library, you can use much larger values. Feel free to modify the code on your own and wear out the 0 key on your keyboard to see how humongous the values get. And if that still does not satisfy you, multiplication is handled in the MPZ_add mul function. Its arguments are the same as the MPZ_add function, though the second and third arguments are multiplied and stored in the first argument. So I will update our existing code here with some lines right before the return statement here. It is about multiplication. So the MPZ underline add mul function here, that performs multiplication, storing the results in the reused variable x. Always recycle, think about our planet. The gmp printf statement outputs the result. So here we go. Well, 3 billion times 5 billions equals 15 quadrillion. But what the, and here you have to add as many Rick Sanchez-like curses punctuated by verbs as you like to match your astonishment. I hope you spied the digit 8 here. It has an 8 in the result. This value is a leftover from the first calculation here, stored in the variable x. And take your fingers out of your ears and note, unlike standard integer data types, you must always initialize an MPZ underline t variable before it's used. In this code, variable x is already assigned an integer value, an MPZ underline t variable before it's used. So if we reuse it, then the bytes, the bits in the value are not reset and still stand there even after the next calculation. To fix this problem, we need to add a MPZ underline init function before the MPZ add multiplication. So that is fast done. I just go here and add. And now you can exhale after holding your breath in suspense. Once the reinitialized to 0, the output is correct now. Here you see there is no 8 visible anymore. Yeah, you can explore the rest of the math functions on your own as they are referenced in the online manual, the API, as shown earlier. Have fun with enormous, large, epic, massive integers in C. If you have further questions, useful feedback, or an idea for a C-related topic to talk through, please leave a comment. From time to time, I will come back on your issues in upcoming episodes. And if you liked this episode, please give it a thumbs up. And if you want to see more videos like this, subscribe to the channels. Don't forget to hit the bell if you want to stay informed when new episodes are released.